So I think we're about time. We ready to start? All right, the doors are sealed. Good morning, everyone. I am Ryan Nowak, and I'm here all the way from Seattle, Washington, as part of the ASP.NET Core team to talk to you all today. And I, for whatever reason, a lot of the other Microsoft people or ASP.NET Core people have been here talking about something new, something that's going to be released in 3.0, or something that's like just released. I'm doing something different because I'm a developer. I'm not a PM. I spend most of my time writing code, not traveling to conferences or giving presentations or writing slides. Kind of just did my best. So I'm going to be doing a little bit of a deep dive, and I'm calling this Lessons Learned Building ASP.NET Core. So a little bit about me. I work on all of these things. So there's kind of a common thread here, which is frameworks and stuff that users touch, but I've kind of gone on this journey from MVC and routing to Razor, Razor compiler, to Blazor, to Razor components, and there's a couple other things in there too. But what I really want to focus in on today is we're going to be talking about the history and the story of ASP.NET Core MVC over the period of .NET Core, kind of .NET Core 1.0 going to 2.0, going to 2.1, and going to maybe a little bit of 2.2, and then a little bit into the future. And we're going to be talking about some of the new things that we've introduced during this time period, some of the changes in the way that the team has thought about things. We're going to look at some extensibility as well and show you some powerful things that you can do along the way that you maybe didn't know about or you didn't have access to in previous versions of the framework. And then I'm going to spend a little bit talking about 3.0, some of the changes that we're making to routing and how that story sort of grows up. So before we get into that, can I see a show of hands? Who is using ASP.NET Core, has used ASP.NET Core? So there's a good number of people in the room. Who has used ASP.NET MVC 5 but not ASP.NET Core? Okay, so there's about a same contingent set of people. So hopefully, if you're not already interested in ASP.NET Core, you're not already a little bit excited about it, you're going to see some things today that'll hopefully make you a little bit excited about it. We're going to be talking about some of the things that we've kind of done differently a little bit or things that we've added. A lot of what you're going to see today is going to be about sort of fundamentals of controllers and pages and routing and those things. And a lot of it's going to seem new because it's additions from MVC 5. Wrong direction. So let's get right into it. I'm going to show you some stuff, and we're just going to spend a little bit of time talking about it. So I have got an app here, and I'm going to go ahead and fire this up. And inside this app, I have got probably the most boring, repetitive demo that you've all seen a million times. I have built a really dumb to-do application. And we're going to look at 3 different versions of that to-do application. I'm going to demo 2 of them. I'm not going to demo the API because demoing API is kind of boring. We're going to look at 3 different versions of this to-do application. We're going to talk about some of the things that make them different. So I am going to go to my to-dos controller. And what do I need to do? I need to give my talk. I need to then get some sleep. And then I need to adjust back to my time zone. So those are some of the things that I need to do. And this is a basic to-do app that you've seen about a million times. I've got a Razor Pages version of this app as well. I can put something in here and I could submit it and it adds to the list. Pretty standard stuff, pretty boring stuff. Let's take a deeper look at what this code is like. So I have got this to-dos controller here, and this is a traditional sort of ASP.NET Core controller. If you have been doing MVC 5 in the past, this is going to seem really similar to you because it's pretty much unchanged. So one of the things that we did when we built ASP.NET Core, and this was a decree of Scott Guthrie, all-powerful VP, is that basically controllers and views, with a few minor exceptions, shall just work. Like it needs to just work. So for the large part, your actual controller code from MVC 5 with a few small caveats, it's just the same. I mean, you're not going to find anything very different. You might find some new APIs and some new concepts, but you're not going to find that very much has been taken out. A few things have been taken out that we didn't really want to bring forward, and we felt like we had good reasons to do. But in general, it's going to look the same. Let's talk about some things that you've got here. So this is the sort of classic version, and right away we've got dependency injection in the constructor. So one of the things that the framework gives you is we new up your class. Anything that comes from dependency injection ASP.NET Core has dependency injection built in at a base level. So one of the most common things that you do is, I'm going to dependency inject my DB context. Okay, not that surprising. Other kinds of things that you can do. Well, we have routing. We route between these two methods, and we still have the similar kind of routing things you're used to. We have the ability to disambiguate between methods that are going to match the same URL based on HTTP verb, which is what you see here. It's another thing the framework does for you. So we see all these action methods. We wire them up to some route table somewhere, and then we pick the best one. We call this action selection or routing. We choose the one that's going to match the request, and then we execute that. Not too different from what you will have seen before. And since we are doing a traditional MVC controller, the really common thing that you're going to do here is you are going to have a view. You're going to do some database access. You're going to have a view. The view name is found by name. It's by convention. And one of the most common things that you're going to do is you're going to create some kind of view model if you're following best practices. If you're hip to that, some people might not like it. You're going to create some kind of view model that you're going to pass to your view. You're going to instantiate that, and you're going to pass your view. So kind of like the things that we see going on here that are provided by the framework is we've got activation, we've got routing, we've got model binding down here, and we've got handling of results, or action results in this case. So something else to point out, all error handling, or all sort of like validation error handling in an MVC controller is explicit. So like, you are responsible for handling errors. I don't know if that's ever been obvious to you or if you really thought about it in the past. Maybe you just scaffolded code or you copied from examples or maybe you did learn this from documentation. But error handling in MVC has always been explicit. So if you want to respond to the user and say, hey, you had a validation error on this page, you have to do that. It's your responsibility. The other thing that I would say, because this is a traditional controller, I don't have anything else here. I just have these two actions. And this is an example of the post redirect get pattern, which is a really common web pattern that's kind of just required for the web to work correctly. You show a form, you do a post, if you choose to accept the post, you redirect the user somewhere else so that they can't hit reload and just refresh the same thing and submit it a million times. We've all seen this before. But you can have like any number of other action methods that are unrelated to this post redirect get cycle that's comprised of these two methods. I just don't have them in my example. So let's look at a Razor page. Razor pages are something that were introduced in ASP.NET Core MVC 2.0, and you're going to notice that there's a lot here that's different, even though it's kind of the same. So we've got this onGet and this onPost method, and they fill the same two roles of what you saw before. So the onGet is like, I want to show the form. The onPost is like, all right, the user sent me the data. Now I want to either accept it or not, and then either redirect them or show the same form again with the validation errors. So we've taken this concept of the post redirect get pattern, and we've made it kind of baked in. And to be honest, this is what Razor Page is optimized for. This was a conscious decision on my part and on Damien's part to say, pages are for these web form-y kind, I realize I almost said web forms, but they're for forms and input processing and data entry and CRUD and those kind of things where you want to show a form, accept the data, and then redirect somewhere else. And the whole thing is oriented around this post get redirect. You can do other things. You can have additional actions and things like that as part of a page, but it's not really the focus, right? With controllers are super flexible and they let you kind of structure things how you want. Pages really optimize and orient for this whole thing. So to add to this, like because this is a Razor page, if I had nothing to do in this onGet method, I could just leave it out and it doesn't matter. It would always just render the view. If I didn't accept postbacks on this page, I could just leave that out and it doesn't matter. I don't need any of that stuff for it to be a page. So it kind of assumes that you're going to scale that way. You're doing web pages that have a page-focused lifecycle, and we're going to add some initialization logic, add some post logic, but we're still within that framework of post get redirect, or post redirect get, sorry. Another thing to note here, validation and dealing with the results of validation, still explicit. Why is it explicit? Well, because in a UI, you need to present that error information to the user. So even though you might just do the boilerplate, like initialize the page and show it again kind of thing, it's still, we need to put a place in the code where you can put your error handling logic, because you got to figure out how you're going to get whatever information that you want to present to the user when you show them that they failed or like they had a validation problem. The other thing about this that's kind of neat is we talked about things that the framework provides you. There are some things here that are common, like activation and routing are still here, right? We're still going to create your page. We still have dependency injection. We still have routing, but it's a little bit different. We've got slightly different rules and conventions, but it mostly accomplishes the same thing. But the handling of results is totally different because pages are optimized around the case where everything you do is going to result in the user going to some Razor view at some point. So like this onGet method, for instance, the action result is totally implied. You don't have to do anything to show the page. In fact, you have to do something if you don't want to show the page. So because we assume that the common case is that you're going to want to keep users in this UI, that's what we optimize for, and we make it sort of the default thing to do. Now let's do something else, or let's look at something else. This is API controller. API controller is something that we introduced in MVC 2.1. An API controller is kind of like, you can think about your MVC controller that's like good at everything, and your page, which is optimized for post, redirect, get, views, HTML. API controllers are optimized for something completely different. So we still have activation, we still have DI and constructors. We still have routing. It's really similar to what we do for traditional controllers. But we're optimizing for completely different things. So one of the things that we're optimizing for is we're optimizing for OpenAPI or Swagger. Who's used OpenAPI or Swagger? So it looks like about a third to a half. So one of the big challenges with OpenAPI or Swagger is, well, you got to have all these features or all these behaviors documented of your API. So if you think about like WSDL or SOAP or some of these older technologies like that, like imagine if you could write a REST API and then you could just have like a document or like a spec, like a contract file for what your API is supposed to do. In theory, that's something that's great to do with REST. Because we're doing C# and because we're strongly typed, we're putting some of that information in the return type. I'm not going to go incredibly deep on this topic. There was some of it talked about in Damien's talks. If you haven't seen some of the things we're doing there lately, I encourage you to go watch Damien Edwards' talk on 2.2 from earlier in the week. But know that that's part of the API controller story is we're optimizing for the assumption that you are building an API, you might care about this open API thing, how much of a complete story and how close to a default good experience can we get you without you having to do work to do it. One of the other things that you're going to notice here, speaking of return types or sort of results of things, is that you see that there's not any validation error handling here. And the reason why that is we've done it for you. So with API controller, one of the things that you get for free, and you can turn it off if you don't want it, is you get automatic handling of validation errors without having to do anything. And the reason, what are some of the reasons why we do that? Well, in contrast to like a website, with a website, you've got to gather a lot of information that you want to present to the user if they made a mistake or they entered something incorrectly. With an API, you probably want to optimize something different. You probably want to have all of your API endpoints behave consistently with respect to errors. And you probably don't really need to put much logic in there. You've already run validation. You basically want to return to the customer or the user or whoever called your API, some JSON blob that says these were the validation rules that failed or something like that. So we've just done it for you because it's sort of just clutter for APIs. You don't really tend to need it too much. So I'm going to jump back to my slides here. And what we're really talking about is kind of the evolution of MVC or the evolution of these programming models. We sort of have the progenitor, which is original controllers and original MVC, which is like, yeah, it can do whatever you want, but it doesn't really bias you in any way or another. And then you have these things like pages and API controllers that bias you towards certain scenarios. So like our traditional controller, as we said, like it eats everything, does everything. You can do whatever you want, but it's kind of verbose because you have to be really explicit about a bunch of things. It's also not really changed because it's kind of just classic. You know, it's an old Cadillac or something like that at this point that kind of just is what it is and it's going to stay that way forever. It's not really an area where we're looking to add more bells and whistles. It's stable, it's well known, it's not broken, it's working pretty well. Razor Pages, jumping all the way over to the right, has got simplified routing and is optimized for a particular set of UI-focused scenarios. We assume that you are doing the common things for views. Something that I didn't point out that I probably should have is in our controller example, we're constructing a view model object and passing that into the view. In a Razor Page, the page handler class is the view model object. You don't necessarily have to create a separate object if you want to. We give you a place to pass state to the view because we assume you're going to do it. We ripped that off from Rails, by the way, which would not be the only thing we ripped off from Rails. Looking at API controller in contrast, it's for REST APIs. It's optimized for Open API or whatever kinds of other things might come along in that space. It has opinions about precise parameter binding and other things like that. We're going to spend a little bit of more time talking about that later because I'm going to show you some things. And it's got that automatic uniform error handling. It automatically does things for you because instead of tailoring each error experience towards who's the customer who's trying to sign up for my email form, it's, well, we want to document what format we return errors in from this API so that our customers can make sense of them because our customer is a computer. So this all kind of makes sense. I'm seeing some nods of agreement. I also want to say, I think of these three things, I kind of lump pages into the same category. And I've got my own definition. I'm going to call it a controller-like because I'm being upfront about the fact that this is not the traditional definition of a controller. I'm instead talking about the structure of the code and how it's implemented rather than what role it fills in architecture. So I would refer to a controller-like as a handler that instantiates an object, calls a method, communicating inputs through method arguments and outputs through method return values. So it's basically this pattern. We activate, we route, which means we choose which method it's going to go to. We bind parameters, which means we're going to have some data to pass into the controller-like. And then we interpret the result, which in our case is a command object or an action result. I think that this is a useful definition because this just works so well in C# and other object-oriented languages. So Ruby's got this pattern, Java's got this pattern, .NET's got this pattern. I'm sure a lot of other languages and platforms have this pattern because if you're doing object-oriented programming, it just works so well. These are kind of the tools that you have available to you. And when I think about designing features or building new things into the framework, I think about the design space in terms of those things. Those are some of the things that users can do in their code. So if we can respond to what you put in your code, or if we can optimize what you have to put in your code, it could be really beneficial to you. It could make your life easier. It could make things less error-prone. So let's step back and take a slightly bigger picture. I haven't shown the startup class of this application, but if you've done any ASP.NET Core before, this kind of thing should be pretty familiar to you. Everything that we have talked about so far is in that ugly yellow blob. So we've got all these other middleware here. We've got developer exception page, we've got exception handler, we've got some HTTP kinds of things, we've got static file serving, we've got a GDPR thing, and then we have use MVC. Use MVC is actually what we call the use router middleware, and it's what hooks routing up to the middleware pipeline. So once you get inside of middleware, think of middleware as like this sequential pipeline. It's a bunch of handlers for handlers for handlers for handlers for handlers, and request processing proceeds through this chain until it gets to routing. And routing is a branch. Routing makes a decision and says, we are going that way, and we're going to home index, or we are going that way, and we're going to the to-dos page. The action invoker is all the stuff that we've seen before, which is like, all right, I got to run your code, I got to run your page, I got to run your API controller. How MVC interacts with routing is, well, we have to figure out what's in your app. And we have to initialize a route table with all that data so that routing can make the right decisions. So wouldn't it be cool if we could check out what that's like? And spoiler alert, we can check that out. So I'm going to boot up this app again. And what I've done in here is I've created an action on a controller, just doing a normal thing, that's going to grab some MVC framework data. And I've just formatted it for a little bit of a nicer display. So you can see in here basically all of these actions that exist. And I'm going to scroll past some stuff and I'm going to look for that first controller that we talked about. So here's our first controller that we talked about, that plain old vanilla controller. You can see we've got the index action. This one's the get one. I can tell that because it has no parameters. And it's got some filters around it. So what are filters? You probably may have heard of filters before, but the way I like to think about filters and the way I want to introduce them to you is they're just middleware for MVC. So filters are like, you've got that middleware pipeline that we looked at before that's like, okay, I'm going to run error handling, and then I'm going to run authorization, and then I'm going to run files, and then I'm going to run routing. Filters are just middleware for your actions and controllers. And it's this big complicated beast. It's got a bunch of different stages and things like that. But really what you need to know about is that they're middleware for your controller. And there are some filters here that are built in by default. I'm going to talk a little bit about more what these are in a moment. Here is our post action, and I can tell that this is our post action because it's got a single parameter down here, and that's this to-do model, and it says binding info model binding. What binding info model binding means to me, it's a terrible name, and you can blame me for it because I created it. But what model binding means to me in this context is it means be as flexible as possible. Because when we think about how our UI applications work, we don't really care that much about being precise about like where the data came from. Did it come from the query string? Did it come from the route data? Was it part of a form post? Like, as long as it's going to get you there, you're pretty much fine with it. And that's all right, because you might have multiple forms that post to the same endpoint or something like that. You want a certain degree of flexibility when you're doing UI programming, because you don't necessarily care. Down at the bottom here, we've got our to-dos page. And you'll notice that there is only a single action here. It's not actually two separate things. It's one thing that makes a decision when it runs, am I doing a get or am I doing a post? There's some somewhat complicated architectural reasons in there, but basically the way to think about it is because pages can be recompiled, we have to sort of like have the branching logic inside the page. We don't know what the compiled type of the page is going to look like and what methods it has and what filters it has and all those kinds of things. We don't know those things when we build the route table. So I actually did some like workarounds to get this data, because if you looked at what's in the route table, the what's called the action descriptor for a page actually doesn't have any of this information. It only is a thing that can be routed to, and then later we create the actual thing, because pages can be recompiled, and also we don't compile all the pages on startup, or we don't have to. It's not a requirement of the system. It's actually a requirement the other way. But this is mostly going to be the same as our controller, because it kind of does the same things. Let's look at our API controller. Wow. So I'm looking at just the post action here. I'm going to skip the get one because it's less interesting than this. But you'll notice that there's like all kinds of filters here. Like it's filters going bananas. The other thing that there is there's this binding info body. Now, what is that? So binding info body is a default parameter source convention that is part of the API controller construct. So rather than model binding, which is like, I want to be flexible, I want to collect all the data, I want to shove it all in one pile and roll around in it, this is going to be very precise. And I'm saying that I expect the body of this to-do item to come from JSON that's going to get deserialized for the body. Now, why would you care about this? Well, it's the opposite of a UI controller. You actually want to define where your data is coming from and what the requests that are passed to your API should look like, because you want to give your customers, who are other computers or other services or other teams at your company, or maybe even external people, a consistent and stable and well-documented contract. So one of the things that comes with API Explorer is that the binding behaviors by default are sort of optimized for the kinds of things that you might reasonably do, rather than expecting you to mark this up yourself. So to look at that a little bit, if I went to this API controller, I could do something like this. And changes are not allowed when code is still running. I'm very sorry, Visual Studio. I could do something like this, and I could be very explicit about where this is coming from. But because it's an API controller, I don't have to do that. It's assumed because it's the most common thing that you probably wanted to do anyway. So I'm just going to revert that. Cool. So hopefully that's a little bit of useful information, the way to think about it. We've got all these sort of filters and all these different things that we collect. We've got the parameter info, we've got the routing info. We build this big table of actions at startup time, and we throw that into routing. And that's kind of how stuff gets to your code. And this is a diagram of the invoker. It's been simplified a little bit. I talked about how filters are complicated. This is how they're complicated. There are lots of different ways that they work. Now I want to change gears a little bit, and I want to sort of distill what we just talked about and think about how I think about moving frameworks forward, how I think about our role in being your partner and helping you build things. So to me, what makes a framework so different from a library is that, like a library, you call this method, it does a thing. Maybe it reads a JSON file, maybe it writes something to disk, maybe it resizes an image, something like that. It does one task, and you're generally, as the application author, you're in control of what's happening. Whereas like a framework, well, does this, right? It's got all these little points to wire up features. It's got all these callbacks. It's got pipelines. It's got extensibility points. And ultimately, we have this concept called inversion of control, which you might have heard in the context of dependency injection, but that's just one meaning of it. Inversion of control just generally means like, all right, you wrote the application, but we're the ones calling your method, right? Like it's not your code 100%. It's maybe your code about 60% or about 40%. And that's kind of the gist of inversion of control is you're going to create something. We're going to be the ones responsible for calling it or sort of plugging you in. So what's risky about this or what's bad about this is like, well, what if we have a bug? And I'll be honest with you, we have bugs. What if we have a bug? What if we don't call your code? What if we don't pass the right methods or pass the right arguments? What if we call methods in a different sequence than we did before? Or like, what if we didn't load your DLL? What if we're not routing to your controller? What do you do if we have a bug? Like, what's your workaround? Sadly, a lot of the time, there's not a workaround. Or it's going to be some awful arcane thing that you're going to log an issue on GitHub, and I'm going to respond with 200 lines of code, and I'm going to say, hey, make a class called this, paste it into your project, wire it up to the solution, wire it up to your dependency injection, and we'll patch this as soon as I can. So those are some of the problems with having a bug in the framework, some of the risks with having a bug in the framework. We also provide a lot of rich extensibility. And everywhere that we've got this rich extensibility is another sort of like risk for your application if we don't do our job. So like if we broke something that you depend on, let's say you wrote a model binder because you need to parse some data, or you want to automatically model bind a parameter from your database or something like that, which is a super common thing that people love to do. Like, what if we break you? What if ASP.NET Core 2.1 works great and ASP.NET Core 2.2 does not work so great? Like, how do you get past that? We've erected this very like challenging barrier for you to get through. The other thing here, frameworks have opinions and opinions change. So like we're doing this open API thing now. Our automatic error responses are something called problem details or RFC 9807. Like, what if that's not the thing anymore in 5 years? Like, is your application still going to be around in 5 years? So you probably do care about this stuff, right? Because like, if you like that and you're still using it and we say, but nobody's using that anymore, we want to get rid of it, like you still have to have some path, right? And even if your path involves you changing code and moving forward, like how can we make that path as seamless and as smooth as possible? We also have with something like API Explorer, at least in my opinion, because so much of your application is our code and our library and our behavior, we have a significant opportunity to add value to you. Because the mix is just a little bit bigger in our favor a little bit of times, or like we can make your life a lot easier. With libraries that kind of stay in their box and do what they do, but with a framework, it's like superpowers. At least that's how I think about it. And then lastly, how does a team come up with a strategy that preserves our ability to keep working on the framework, keep making improvements, and keep making changes? So I want to show you some real bugs that we have had and some real problems that we have fixed, and how these issues can be kind of vexing, really. Like, I think when you see, hopefully when you see some of these bugs, you'll agree with me that it's not necessarily as straightforward for us as like, well, we'll just fix the bug, because there are some other concerns that come up when we start talking about functional bugs in frameworks or changes in behavior in frameworks. So I'm going to use that term a lot, breaking change of behavior. So I think there's a good talk that John Skeet is doing next that's going to be better than anything that I can say about it. But the world is broken down into changes and breaking changes and all kinds of different changes. And the way that I think about it is that every change can be a breaking change to somebody, and there's different kinds. You can break source compatibility, you can break binaries, or you can break behavior. And I'm really going to focus on breaking changes in behavior because I think I've got some pretty good examples here. So here is an example page that I wrote with some really hacky fetch stuff. And this is going to do some asynchronous data posts to the server to do some things. I haven't shown you any of the code yet to know what it's doing yet. I'm just going to describe it. And you're going to see results down here in this kind of low contrast text box at the bottom. This is about as good as my UI stills get. If you've seen the Blazor stuff, the Razor component stuff, I maybe wrote some of those application parts. I did not write any of the UI. Steve Sanderson did that. So I am going to post to this controller, and uh-oh, I've got a problem. I hit an exception. So I have written my own input formatter. I don't know if anybody in the audience has ever written an input formatter before, but an input formatter is like the thing that deserializes request bodies. So if you're reading JSON, you've got a JSON input formatter. If you're reading XML, you probably have one of the two XML serializers or XML formatters reading that. If you wanted to hook up YAML to ASP.NET Core, you would take a YAML serialization library and then you would use an input formatter to plug it in. So it's the place where we integrate. So cool, so I have an exception. Who thinks they knows what this exception is going to do? Is it going to crash the application? Is it going to give me yellow screen of death? Is it going to give me back a 500? Graceful? Think about it in your brain. I'm not going to ask for participation, but think about in your brain what this is going to do or what you'd like it to do if your formatter was throwing an exception. And keep in mind, this is an assembly load exception, and that's on purpose. So I'm going to continue. And we get a message here saying, oh, an error occurred. We're real sorry about that. And I think I failed to reset my demo, but I'm going to check that real quick because I might have made a mistake here. But anyway, I'm going to keep explaining while I keep looking. We had a bug. Yes, I did. I forgot to reset my demo. My bad. We had a bug in ASP.NET Core 1x and 2x and so on, where if an input formatter threw an exception for any reason at all, it would get swallowed by the framework and it would get turned into a normal validation error. So there's actually good reason for that, but it was still bad. So here we are again. I throw an exception in my formatter, and I get this generic the input was not valid method. So the problem is the infrastructure that calls input formatters swallows all exceptions, just eats them all, and turns them into validation errors. And the reason why is that a lot of the built-in serializers in .NET, XML serializer and XML data contract serializer, throw an exception when data is invalid, and they have no other way to report that the data was invalid. So if you posted invalid XML to the server, you would really prefer for that to come back as a 400, not a 500. We work with a lot of customers that have monitoring services. And if you have a monitoring service in production, or if you have an IT organization that uses a monitoring service to watch things, or if you get alerting from your monitoring service, you know that you don't want 500s occurring in production, because even if they're sort of benign, it makes it hard for you to catch real problems. So you start getting pinged by people that are sort of like, I'm seeing all these 500s, I'm seeing all these crashes, and it's like, well, reporting an error correctly and saying this is bad data versus this is a crash, like it's actually really important in these production kind of scenarios, even though it doesn't crash the app. So we had a bug. And if you were with us through ASP.NET Core 1.0 or through the DNX days, and I'm sure that there is at least one, DNX OG here, he's laughing probably. He's crying, just remembering it. I think the thing that he's remembering specifically is that in ASP.NET Core 1.0, it could have been really hard for you to get the right set of assemblies in your application, like the right versions of assemblies in your application. And we've kind of cleaned that up. But if you had that kind of problem, one of the places that you were very likely to blow up was reading the request body, because it could be the first time that a bunch of those assemblies are getting loaded to do like I/O. So we got this like rash of issues reported by people that were like, well, I'm getting this invalid model exception, and I have no idea why. And then we tell them, well, this is where you look to look at that data, and they look at that data and they say, oh, but that error has an exception associated with it, and the exception is like invalid type load exception or something like that. And it's like, oh, holy crap, like that's really bad, right? So we're silencing all these really bad application deployment and configuration problems and representing them as like a validation failure, which is really, really bad, right? And the reason why is because we have to work with some libraries that use that exception as their success path. So this gets to customers before we realize we have a problem. So what do you do? Because like it is a breaking change of behavior to this interface, right? This is a somewhat common, somewhat high profile extensibility API. And we had this behavior before where we just handle all exceptions. We just eat them and we turn them into model errors. I've got another cool bug here. So I have got a controller that is model binding an enum value. And that enum value has got 3 values. It could be dog, cat, or fish. So if I put in dog here, it's going to say everything's fine. If I put in cat or fish here, it's going to say that everything is fine. Cool. If I put in something that's out of range, like let me put in unicorn or unicron, both good. But I know that I don't have a unicorn element of this enum, and it's going to tell me that. It's going to say that's not valid. That's good. That's what you'd expect. That's what you'd want. Cool. What if I put in 0? Well, 0 works because 0 is a valid member of this enum. And some serializers, JSON.NET does this in some cases, some serializers will serialize enum values as their integer equivalents. That's totally valid, right? It's just a different way of representing the same information. Okay, fine. So my values of this enum are 0, 1, and 2. What if I put in a different number? What? That works? It does work. So the reason why is because an integer, or an enum, this enum in particular, is represented as an integer. And .NET is very happy to convert some arbitrary integer into your enum, even though it doesn't match one of the enum values that you've defined, because it is possible. The language allows it. It's a technically possible thing. And so the normal code paths that you go down for enum conversions don't enforce this. They'll let you convert some random enum value. You can even make this like a negative number. Like it could just be any number that can be converted to an int32 will work. So like we did what .NET does. We exposed that over the internet. And then we found later, it's like, oh, this is a bad default for the web, right? This is a bad default for our users. Another thing that comes up here, I want to validate some data. We have an email sign-up list. I have a required validator on this thing. So I submit my email address. That is my email address. You can email me if you want. I submit my email request to sign up for this mailing list, and it validates it, and everything is fine. Cool. Let's do something else. What if I submit an empty? I have a required validator on here. Oops. That works. The reason why that works is that you might be blown away by this. I might blow some minds, but MVC never had support for this. Web API didn't either. It was not a feature we had. So like validation attributes on parameters directly, which is what my code is doing. I have a string email address with a required attribute on it. It's legal. The code compiles. The data annotations attribute, which is from the .NET BCL data annotations library that's been around forever, allows being put on parameters. But we just never had this behavior. It was never present in MVC. It was not present in MVC1. It was not present in MVC2. And like, if your mind is blown by that, you probably are thinking like, well, surely you can fix this. Like, why wouldn't you want that? Everybody would want that. It seems obvious that that should work. And the answer is, well, we felt the same way. We really wanted this to work as well. So we added it. So I'm not gonna show the second half of this, which is that we were able to fix the bugs just for time. But basically, we were able to fix all these things. And the way that we're able to fix all these things is that we were able to come up with a strategy for how we want to manage this and how we want to manage change going forward. So a couple of things that we thought about. Just saying like semver, and like semver means we can make breaking changes, I think is not good enough. Like you can picture, like if you've seen The Hunchback of Notre Dame and you can picture like running into the church yelling like, semver, like that's not good enough. Like we can't just say to our users like, we will break everything, we will change everything in 3.0. It's gonna have all these subtle little things in it. That's not quite enough. That's a little bit too harsh. We could say, we're gonna just fix these things. We're gonna just fix these things, right? That's not great either because it only works for really small issues. We can't really just fix the parameter validation thing because it affects a bunch of extensibility. We can't really just fix the exception formatter thing because it's a breaking change. So you get in the situation as a team or as a product owner where it's like, well, we can't change this stuff because it's too risky, it's too expensive, it hurts our customers too much because all of these problems require a code change and a redeployment from our customers. So not only do you have to upgrade to the new version of ASP.NET Core, and you have to like deploy it somewhere, you got to test everything to find these problems, including invalid data, and that's why they're so risky. Second thing, we could add more options or settings. We could take all these different things and we're going to say, we could make all of these things optional behaviors that you can choose. If you think that enum thing really makes sense to you, you can leave it the old way. If you like the new behavior, you want it to be validated because you're sane, you opt into that. The big problems with that, again, only works for small stuff with a really minimal impact. And two, when we add options, they have to be off by default because otherwise you're back at breaking changes. So at best, you can give people that know they have a problem a workaround, which is not a great, it's kind of the minimum you could do. So what we did instead is we did this thing called compatibility switches. And you can think of it like a hybrid of sort of all those options. If you have looked at your templates or you have looked at your application at some point in your life since 2.0 and you're doing ASP.NET Core, you have probably seen something like this compatibility version 2.0. And you can see that we've got 2.1, 2.2, we've got all these different compatibility versions. And it's as simple as it sounds, right? So every time we fix a bug or we make a small change like this, we do that in some release. That fix, that change in behavior, gets a switch that's associated with the version of that release. So for you as an application author, you take your app, you upgrade from 2.0 to 2.1, you replace the binaries, right? You get the package references to 2.1, you follow all the migration guidance. The migration guidance calls out the things that have changed that are associated with compatibility switches, because we think you should know about them. And you can leave that compatibility version at 2.0 for a while if you want. Like, you can run the 2.1 binaries with the 2.0 behaviors, and that's basically what compatibility switches give you. You get to take these things at your own pace, and you're not blocked from getting like new features necessarily, or new stuff that requires 2.1, or performance improvements, or minor bug fixes, or platform upgrades. So it gives you like a smoother cliff to upgrade and integrate all these things. The other thing that we do here is that on these options objects, I'm going to have to get used to typing on this pedestal, so you guys are going to have to bear with me. We have got options for all the things that we add compatibility switches. So this is that exception input formatter one. So if you want to upgrade everything, but for some reason you're like blocked on this one, you can leave it alone. You can revert to the old behavior, and you can micromanage these things if you want to. I don't know many people who do, but it's there in case you need it. The other thing about this is that we sort of declare amnesty for ourselves on major versions. So we still intend to get rid of old busted stuff. We still intend to make MVC the best version of MVC moving forward. But we want to give you like a really nice roadmap to move forward with these things, and a really nice way to take these upgrades in chunks. We also reserve the right to leave old behaviors behind if they make sense to leave behind as options. So doing this compatibility switch thing is good from our point of view because it gives us a chance to get feedback from people. And then if a lot of users are like, well, I really need this thing, then great, we're going to leave that thing. And you can think about which option is better for you. We'll decide a default, but if you like the old behavior, you can keep it in some cases. So that's the compatibility switch. That's kind of the journey that we've been on. Now, why don't we have them in other areas of the stack? We don't have compatibility switches yet in other areas of the stack, like in the HTTP layer, simply because it hasn't come up. We haven't felt like there are issues that are sort of worthy of it in those parts of the stack because they're not as frameworky, and the kinds of problems and solutions you have if you're a user are not as thorny to work through. But I'm not saying never. We might do it if there are good scenarios for it. Now I want to show some more code. So we're going to talk about filters in a little bit more depth. And filters are this like power feature of MVC. Now, I showed you that list of actions before, and we saw all those filters that are on all those things. In particular, API controller had like 1 million filters on it. And we're going to examine a couple ideas for filters, a couple things sort of about their nature, and hopefully you'll learn some stuff or get inspired by this. So you notice in this some bugs thing, now that I'm in 2.2, I'm just going to run it again while I'm talking about this. Now that I'm running in 2.2, if I hit this crashing JSON exception input formatter case, which I want to crash because it's an assembly load, it's a deployment failure, I am going to get a friendly JSON error. So here's my exception again, and I get this friendly JSON message here. Well, this is coming from my code, and this is coming from a filter that I wrote. So if I come down here to this errors folder, I have got this JSON exception filter attribute. And if I look at where that is applied, and I realize that's kind of small, I have got this on the bad formatter controller. So what you can learn about this is that, well, it kind of does the obvious thing. I've got this attribute on the controller, which means I've applied this behavior to all the actions on my controller. If I wanted to apply this behavior to, say, my whole app, there's a way to do that too, which we'll see in a little bit. But looking at this guy a little bit more, I'm going to handle exceptions that come from these actions. I'm going to respond with some message with some severity level, and I'm going to put that in an object result and give it a 500, which is basically saying like you're going to write this to as JSON or XML. I want to do something with this severity thing. So I've got the default sort of setting here for severity set at nah, relax, it's okay. Like, could I change this setting? Well, sure, I could modify the code, right? But could I build a system such that this severity level can be like toggled up and down for individual actions? One thing that I could do is I could make this like a parameter of this filter. That's kind of obvious, right? But what if the severity is a part of like multiple filters, or like multiple systems need to interact with this severity? I don't want to couple it to the exception handler if I'm using that severity also for logging and different things like that. I might need to use it for multiple places, so I want to build it in a way that's decoupled. How can I do that? Well, this filter is an example of something that I'd refer to as an active filter, meaning that it implements an interface. It does something. So this onException method hooks up to the invoker and is part of a lifecycle to kind of do stuff around your controller, or like meta-program your controller. But I can also have filters that are what I refer to as passive filters or as metadata. And as an example of that, I have created this JSON severity attribute. Now, the only thing that you really need to know about this, the only thing that makes this special is this iFilter metadata and iException severity. So this iFilter metadata is an MVC type, and it basically says to the framework, when you see this on a controller or on a global or somewhere, I want you to retain that information so that I can get it later. So if you've ever found yourself like writing filters where you do reflection over your own code, which attribute is applied to what, there's a better way to do that. And I'm going to show you that right now. So if I come to the startup class of this, one thing that I can do is I can add this thing as a filter. So filter is add, and I'm making it a global filter, say exception severity attribute, and I'm going to say that the severity is going to be, someone should look into that, because somebody really should look into that. I'm going to add this as a global filter, which means that for any action in my application, I should be able to look at that. I should be able to look at the set of filters or the set of data associated with actions, and I should be able to see this policy applied to it or this metadata applied to it. And then the other change that I have to make is here inside my exception, I have to get that data. So I can do something like this. I can say var policy equals to context.find effective policy, and I'm going to put in the iException severity interface. So I'm basically going to look at the collection of metadata for the current action, and I'm going to see, do we have a policy applied to this action that sets the exception severity? And then inside here, I'm going to use that, because I should probably use it. And we might not have one, so question mark dot, and we're going to use the severity, and then fall back to this. Just relax. If nobody cares about the severity of this thing, then it's probably not that important. And then to sort of prove that this works, I'm going to go to my bad controller here, and I'm going to put a exception severity on my controller, or on this action. So I can put my exception severity here. Exception severity, severity, and we'll say that this is on fire. This is really important. So if I run this again, what's going to happen is I've got this sort of default of like everything is cool applied to everything, but then I've overridden that metadata, or I've specified a more specific metadata for just that action. So if I run this now, I get my exception like I expected, and then I get down here and it says that everything is on fire, which is just what I wanted. So filters already have this kind of like scoping policy, or this scoping behavior where like if you put something on an action, it's considered more specific than something on a controller, which is more specific than something that's global. There are all kinds of ways to control the ordering of things in filters. But you can do that to build these systems that do metadata, or kind of like build your own extensibility into things in a way that works the way that's kind of obvious if you think about how you'd want that to behave, right? An attribute on the method is more specific than an attribute on the class, and so on. So what else can we do with this? Well, if I wanted to, let's say my application really takes off because people love this app, And let's say that I have got a bunch of places that I have this JSON exception filter sprinkled around. That's kind of annoying, because what if I forget to leave it off? Then my error handling is incorrect. What can I do about that? Well, one thing that I could do about that is I could come back to the startup, and I could also make this a global filter. So I'm going to add that filter here as well. JSON exception filter attribute. And now this should be wired up to all the actions. So can anybody guess the problem with this? Well, the problem with this is I've applied it at the global level. So if there's any actions that I don't want JSON handling for, or I don't want to treat errors as JSON, like say an action that's supposed to be used from the UI, then it's going to give me the JSON error, even though I didn't want it, because it's applied globally. So could we do something smarter? And the answer is you can. You can do some of the kinds of things that we do internally. I want to introduce something now called the application model. I'm going to move kind of quickly through this. But if there's anything that you take from this, this is how features like API controller that are really powerful and smart are built, is for us through sort of a combination of filters and something called the application model. So I'm going to nuke this, because we already know the problem with that. And I'm going to come back here, say options.conventions, add. And I've already written this new JSON exception filter convention. And how this is going to work is I define this convention, and I've made it a controller model convention, which means it's going to evaluate once per controller in the app. And what I get here is I get this thing called a controller model. And this has got a bunch of different junk on it. So it's got the list of actions, and it's got models for each action. It's got the controller name, the controller type. It's got the collection of attributes, so you don't have to query them yourself if you don't want to. It has got the set of filters. It's got a property bag that you can dump things in, and it's got all the routing information as well. So what I can do with this is I could apply my JSON behavior to just my APIs. And I could do that by saying something like this. Is API controller, and I kind of duplicated some logic from the framework here. We should probably make this available. But I'm basically saying if you've got the API controller attribute, or if it's applied at the assembly level, then it's an API controller. So if is API controller, controller filters add new JSON exception filter attribute. And this has done the same thing as we did before of I'm going to apply this JSON error handling policy, but it's just going to be limited to your APIs. And it's kind of like out of sight, out of mind, right? Like if you're the person who manages infrastructure for your team, and a lot of other people sort of manage the code or work on different parts of the application, like it's a good way to kind of like make sure that policies like this are being applied uniformly and are being like rolled out in ways that make sense for your team and kind of managed centrally. So think about doing some of these things if it appeals to you. So when you look at like API controller, that attribute is effectively just that code I showed you times like 5, where we say, we have a bunch of conventions that say, is this an API controller? If it is an API controller, register a filter. That filter does something like automatically respond with your validation errors. So there's kind of a difference there that gets drawn out pretty quickly between something like Razor Pages, which has a lot of special behaviors, but those behaviors are built into the framework. They're kind of baked in. Versus something like API controller, it's just a controller. All those behaviors are layered on top, all done with conventions and filters. Very powerful stuff. I'm going to quickly move through some more slides because I'm a little bit behind where I wanted to be. I want to show you a little bit more stuff. So let's talk about middleware and filters real quick. Middleware are this pipeline, right? They're this decorator pattern or this chain of command, pick whichever description you like, or chain of responsibility. You run logic, you call next, you run logic, you call next. It's got an async before-after pattern. Run code before something, run code after something. Filters essentially do the same thing, but there are more different ways to do it, more stages, more information about MVC in there. If we could compare those, they're both ordered pipelines. They're both terminal in the sense that they both can be terminal, meaning that they allow you to short circuit, right? So if you think about a security middleware, it's going to short circuit you, say you're not authorized, go away. They can mutate the request and response to affect what happens after them or on the way out. But then they start to become different. Middleware all happen before routing, and so they don't know anything about routing. They don't know anything about your actions. They can't look at your filters. They can't look at your metadata. They can't do anything like that. They are global. Filters can be scoped. They can be applied with conventions. They can be applied statically at all different levels of granularity. Middleware, since they all appear in your startup code in a simple, like kind of single order, it's very easy to reason about the order that they run in. Whereas filters, like the ordering between them is kind of opaque, right? It's complicated. There are many phases, and the tools that you have for ordering them are pretty poor. Middleware supports many things that filters do. We have many implementations that are common between filters and middleware, like cores, like response caching. But we also have some things that are just implemented in filters, like authorization. There has never been an authorization middleware in MVC. If you want to secure a middleware and have it check that the user is logged in, sorry, you're going to have to write some code because we don't provide an authorization middleware. So we've kind of siloed ourselves here by putting a bunch of things in both places and duplicating the code. We put a bunch of things in MVC where they're tied to MVC, and that's really the only way to use them. But there are more frameworks than MVC. There are good community projects like Carter or like NancyFX, and there are other frameworks that Microsoft ship like SignalR or like soon-to-be Razor components, right? And we have the sort of challenge of like, well, if we build SignalR, we build something like that, what features do we have to duplicate now inside of this thing and provide different ways of getting at because it's separate and it can't reuse what's in MVC. So wouldn't it be cool if we had a way to take the best of both of these things? So now we're talking a little bit about 3.0, and if you've heard about endpoint routing and you've seen the Preview 2 announcement blog post, anything like that, endpoints are a new primitive that's part of the middleware pipeline. And inside the middleware, it's like the middleware pipeline, but it's got routing as well. So you can think of it as like if middleware had access to routing information, if middleware had access to filters, if middleware could do all those things that they could do. So in this model, endpoint's a new primitive, and it's basically a middleware plus metadata. It's a middleware that you can ask things about. What are your interests? Where did you come from? What are you doing here? What's your cores policy? That kinds of small talk kinds of things. In this mode, you've got middleware acting as the active filters. So things that do stuff are middleware, and the metadata themselves are the passive filters, meaning that they just apply data to things. And we think that that combines the best of the two systems. Now, a lot of this stuff is still being developed and is still sort of being worked towards here. And I am basically out of time. So I'm going to kind of introduce this, and I might show one quick demo, but I am basically going to be out of time here. So let's take a look at this future application that I've built. And this is based on Preview 2. So I have got this use routing method. And it's going to look kind of similar to what you might have today, where you've got MVC and you've got some routes for MVC, but you also can have random lambdas. You also can have a random function here. You also can have health checks, and it's all just routing. Now, wouldn't it be cool if you could apply metadata to these things? So what if I could say, on my health check, I'm going to add my JSON exception policy, which is similar to the thing that we just showed in the last thing. What if I could take that JSON exception handler behavior and I could attach that to a health check? What if I could take this thing that is going to map all my routes and I could say, I want that to require authorization, which this is basically the equivalent of like the authorize attribute from MVC. What if I could start sprinkling this stuff all around different things? And what solves a problem about this, or what problem solves here that I like, is something like health checks doesn't know anything about authorization or JSON exception handling or any of these other kind of cross-cutting features. They just kind of come for free. They're just kind of part of the middleware pipeline. And then to kind of show, I'm not going to be able to show my whole demo, unfortunately, but I want to show one thing real quick, which is I'm going to run this application and I'm going to show you basically some of the same information that we saw at the front. And I'm .NET running because I can't get Visual Studio to do this for whatever reason, so I'll figure that out later. But I'm going to show you the same kind of information that we had before when we had our list of actions and things like that. I don't know why this is taking so long. They would also like me to remind you to please evaluate this session on your way out. Thank you. I don't know why this is taking so long. There it goes. Okay, so let's grab this real quick. The rest of my demo, by the way, which I'm not going to be able to get to, unfortunately, was to code up that whole flow that you saw with the exception handling JSON thing with middleware, and with the same set of features with middleware, and then be able to also apply those kind of policies with the same level of granularity to both those lambdas and health checks and your actions and all that stuff in one system, all with middleware. So you can see you've got your home controller, you've got your endpoints list, and you've got all these other Lambda things here also listed with their own metadata. So you can see I've got my JSON exception metadata attribute here. In fact, I've got 2 because I love it. So we're starting to have a lot of the same things that we have with MVC, but at sort of a middleware kind of level and a more primitive kind of level that like other frameworks and other very low level things can take advantage of. So it's like we're kind of sharing all the love of MVC out with the world. So anyway, I'm going to have to end there because I'm over time, and I want to let you guys have your break. This is the end. So thank you very much for listening and being a good audience. And please feel free to reach out to me on Twitter or GitHub if you have questions or things you want to talk about. ASP.NET Core is always the best place to post issues or ask questions, and hope you enjoy the rest of the day.